Last week, NASA announced that they would delay the next flight of the Artemis program, Artemis II, from September 2025 to April 2026. They also announced the results of the comprehensive investigation into problems with the Orion spacecraft's heat shield, and that the agency would fly Artemis II as is, but with a modified re-entry trajectory to mitigate the issue. Since then, NASA has come under fire from pretty much every angle. Some say NASA is being too conservative because the charring issue would not have put astronauts in danger. Others think NASA is being way too cavalier in flying Artemis II as is. The heat shield has already been bolted onto the spacecraft. To change the heat shield would mean a delay of more than a year, and some think NASA is too deadline-oriented and is compromising astronaut safety. Still others understand the decision but don't trust NASA because of their reluctance to release information around the issue. I'm Swapna Krishna, and today on Ad Astra, we're going to go through what we do know about the heat shield issue, what we've learned about NASA's safety culture since Columbia, and whether I think this is a good decision on NASA's part. Let's start with a brief summary of the problems with Orion's heat shield. If you want the in-depth version, I have a whole video on that subject, so check that out. But the short story is that during the Artemis I flight, Orion's heat shield behaved in unexpected ways. The heat shield covers the bottom of the capsule, 16 feet in diameter, and is made of a material called avcoat. Avcoat is the same ablative material that was used in the heat shields for the Apollo missions. We have a lot of experience with it, and we know how it's supposed to behave. What happens is, during re-entry into Earth's atmosphere, Orion can experience temperatures of up to 5,000 degrees Fahrenheit or 2,760 degrees Celsius. At those temperatures, Orion's titanium skeleton and carbon fiber skin would basically melt. The avcoat ablates away, charring in order to protect the capsule and the crew inside. Or at least, that's what it's supposed to do. After Orion touched down in December 2022 and examination of the capsule began, NASA noticed that the avcoat heat shield layer had chunks missing. The material was charred, and that's supposed to happen. What is not supposed to happen is that the charred material cracks and breaks off in chunks. This happened in about 100 spots on the Orion capsule. As you can see in some photos here, there are holes in the heat shield. NASA needed to know why. The thing is, we've flown Orion before on an exploration flight test, or EFT-1, in December 2014. The heat shield was tested and there were no problems on EFT-1, but there were also some big differences between EFT-1 and Artemis I. Let's talk first about skip entry. If you've watched my videos covering Starship's re-entry, you know that the ship hasn't done an orbital flight test yet. All of Starship's test flights so far have been suborbital because orbital re-entry velocity is much greater than suborbital. SpaceX needs to get their heads around what a suborbital re-entry will do to their spacecraft before they move on to orbital. Well, the velocity of coming back from the moon, that's even greater than orbital velocity. So NASA takes steps to slow the Orion capsule down using a technique called skip entry. The capsule basically dips in and out of the atmosphere, which reduces the spacecraft's velocity. When it skips back up into the atmosphere, this is called a skip dwell, and that will become important later. This was a technique first attempted on Artemis I. There were other relevant differences between Artemis I and EFT-1, though. First of all, the basics. Both the re-entry velocity and temperature of the flight test were lower than they were for Artemis I. EFT-1 was a 4.5-hour orbital flight test. It didn't leave Earth orbit, and it certainly didn't go to the moon like Artemis I did. While NASA did raise Orion's orbit to test the heat shield, re-entry velocity maxed out at about 20,000 miles per hour, or 32,186 kph, and the temperature maxed out at about 4,000 degrees Fahrenheit, or 2,200 degrees Celsius. In contrast, the maximum re-entry velocity for Artemis I was around 25,000 miles per hour, or 40,000 kph. That's Mach 32, or 32 times the speed of sound. The temperatures were up to 5,000 degrees Fahrenheit, or 2,760 degrees Celsius. The application of AVCOAT was also different between Artemis I and the Orion EFT. For the flight test, the AVCOAT was applied individually. Workers filled 300,000 honeycomb cells by hand, one by one, with the ablative material, after which they heat cured it. That's also how it was done for Apollo. As you can imagine, this is a painstaking and labor-intensive process. For Artemis I, Lockheed Martin and NASA changed the application process. Lockheed Martin builds Orion, but it's under a cost-plus contract. That means NASA owns and operates the vehicle and is intimately involved with every step and every decision. It's very different from, say, NASA contracting with SpaceX for astronaut flights to the ISS. For the Artemis program, they have manufactured AVCOAT blocks that are carefully designed to fit a particular position, and then they're bonded onto Orion's carbon fiber skin. They work with 186 blocks total. Each block is anywhere from 1 to 3 inches thick. It's a huge time and efficiency savings, and it was supposed to work the exact same way as the more intensive process. But this was the first thing that occurred to me when we learned about the heat shield problems. Now, NASA hasn't actually released the independent review team's findings. I'll talk about that decision a little later. So we have very little insight in how all this came together. But what we know now is that some of these differences did matter. Let's break down what NASA disclosed last week. If you watched my coverage of Boeing Starliner, then you know NASA cares a lot about root cause. If astronauts had been aboard Artemis I, nothing would have happened to them. They would have returned safely and wouldn't have experienced even an increase in temperatures inside the cabin. But NASA has had experience with crew returning safely when something is acting in a way it shouldn't. They've learned the hard way with both Challenger and Columbia that if they don't take the time to understand the root cause of aberrant behavior, it can lead to tragedy. So they have basically spent the 2 years since Artemis I ended looking for the root cause to this issue. NASA and the independent review team found that one of the issues that contributed to the char loss from Orion's heat shield was the skip entry technique. What they learned is basically that during the skip dwell, which remember is when the capsule climbs back up into the atmosphere, the heating rates on Orion decreased and gases started to form inside the AVCOAT. The other issue here is the permeability of the AVCOAT. Basically, the ablated AVCOAT produces this gas when it burns without oxygen. But as a result, the AVCOAT must be permeable, because if it's not, that's what causes the gases to be trapped versus being able to be released. The production of gases during that skip dwell time were unable to permeate the AVCOAT layer, so the internal pressure within the heat shield built up. This led to cracking and then to the liberation of the charred material. Now, there are a few reasons NASA was unaware of this issue before Artemis I. It's important to remember that in a lot of ways, this was still a flight test. That was why it was uncrewed to test the entire vehicle, Orion, and SLS to iron out any kinks before putting crew on it. But still, why didn't NASA catch this if they have a lot of experience using AVCOAT? Well, first, the AVCOAT used during the Apollo mission was robust. We had a lot of experience with it, but it was different in some ways than what's being used today. Specifically, there were materials used that we can't use today because of environmental regulation. Plus, a lot of knowledge on heat shield construction was lost when the Constellation program was canceled under President Obama. This is also a concern with the new administration. If they slash budgets and personnel, a lot of institutional engineering knowledge will be lost. We have seen it before. So basically, there was a gap in knowledge on how to formulate the AVCOAT. That meant there were very small changes in the material between Apollo and now that may have affected performance. On top of that, there is the issue of the AVCOAT blocks. Because this was a big change, they tested extensively to make sure it worked before they put it on Artemis I, and they got the construction of it right. The thing they missed is specifically in regard to the skip entry. They assumed that basically if it worked higher in the atmosphere and lower in the atmosphere, it would work the entire way. But they didn't take into account the specific skip dwell time. And when they were developing this technique and testing it, NASA did not have the capability to test the varied heating rates during skip entry. They have since developed the capability, which is how they were able to recreate this issue. Now, let's talk about that block avcoat application. It turns out that the hand honeycomb technique of Apollo provided a separation between the avcoat. It would absolutely crack, but because it was basically in a titanium honeycomb design, it wouldn't spread across the vehicle. When it's in these blocks, and the blocks are designed in a way that they fit together seamlessly, if one area of avcoat cracks, it's not limited to that area. So, why don't they just go back to this method? Well, Orion is a lot bigger than Apollo. Apollo's command module was 12.8 feet in diameter versus Orion's 16 feet. The material that the capsule itself is made of is also different. What NASA and Lockheed Martin discovered when they applied the avcoat by hand to the EFT capsule was that it was much harder to do than during the Apollo era. Because of the size and the material the capsule was made of, it was flexing on them, and that didn't make for a great process. That's why they shifted to the blocks method. So now, let's ask, what does this mean for Artemis II? Artemis II is designed to be about 10 days long, and it's going to be the first mission with crew. Astronauts won't land on the moon. The mission will go around the moon and come back to Earth on a free return trajectory. But because of this, they will experience those higher temperatures and that higher re-entry velocity versus just hanging out in Earth orbit. Now, Artemis II has been delayed from September 2025 to no earlier than April 2026. The first moon landing, Artemis III, is now delayed from September 2026, a date that I really don't think they ever could have made, to mid-2027. NASA didn't make this direct connection, but the extensive Orion heat shield testing is likely the cause of that delay. There are other problems to work through: ground systems issues, abort system fixes. I go through all of this in a previous video on why I didn't think Artemis II could make the September 2025 date, so check that out if you're interested. But basically, I think that they've been delaying big decisions because they've been waiting on the word about this heat shield issue, and that makes it too strenuous to continue towards that September 2025 date. The other big change is that NASA is changing the re-entry profile of Artemis II and moving forward with this heat shield rather than pulling it off and making a new one. If they'd chosen to replace the Artemis II heat shield, that would have pushed Artemis II from September 2025 to late 2026, early 2027, and then Artemis III would have been at the end of 2028. It's important to note that these changes will constrain available launch windows for Artemis II. So while Artemis I had a window every 12 days, Artemis II will have that cut by about 50%, which is considerable. This is going to be a much more difficult mission to launch, and Artemis I was not easy if you recall, though extensive tanking tests should cut down on the propellant loading problems we had during that launch cycle. For the re-entry profile, one thing they're doing is reducing the amount of skip dwell time. NASA believes that the generation of gases that will occur during the Artemis II skip dwell time under this new profile is low enough that they won't build up pressure to crack the heat shield. NASA's run these tests, and they're confident with their decision. For Artemis III on, the heat shield will incorporate changes to make the avcoat more permeable. But one concern for Artemis II is that the heat shield for the capsule is actually less permeable than the heat shield for Orion on Artemis I. According to an article on Ars Technica, which included an interview with Paul Hill, the leader of the independent review team. One big concern was that, in order to examine the strength of the attachment between the avcoat blocks and Orion's carbon fiber skin, NASA uses ultrasound testing. They found it difficult for Artemis I because the avcoat was permeable, so they made the Artemis II heat shield even less permeable, which means gases will build up even faster than they did for Artemis I. As a result of this revelation, and generally the decision to fly a capsule with a known flaw in its heat shield, NASA's come under some fire. It's no secret that the agency is in a time crunch here. The rhetoric about beating China to the moon during this press conference was very interesting, considering I'd never really heard much about that previously from NASA. In my mind, that makes it very clear they're concerned about President Trump slashing budgets because he's not happy with the progress of Artemis and are trying to emphasize their forward progress. That makes sense. But NASA is not a deadline-driven organization. Even at their darkest moments, during Challenger and Columbia, they were not caving to schedule pressures and compromising safety. There's an amazing book on this called The Challenger Launch Decision by Diane Vaughn that I highly recommend and will link here that makes clear that the conventional wisdom about Challenger is wrong. NASA was not desperate to keep to a schedule and did not knowingly compromise safety. Instead, the decision to launch was a result of a combination of problems, including NASA's organizational culture, which led to these tragedies. I had a lot of questions about whether NASA has fixed their safety culture since Columbia, and I dove into this question and how NASA assesses risk in a video about Boeing Starliner, which was, in my opinion, the biggest safety issue the organization has faced since Columbia. But I think the thoroughness of the process during that period showed a lot of us that NASA's safety culture does seem to be intact. Their determination to find the root cause of these thruster issues, even as everyone was criticizing them, gave me some confidence. And that does extend here. Paul Hill, the leader of the Independent Review Board, was a flight director at NASA. He knows NASA inside and out. He also understands the organization at its worst moments. Hill led the accident investigation team for Columbia that was in charge of recovering debris, analyzing all the sensor information from various government agencies, and radar testing. He was also the flight director for the return to flight mission after Columbia, and he understood intimately the thoroughness necessary for an investigation like this. There have been questions about whether NASA is caving to time pressure by using the Orion heat shield for Artemis II. But Hill said to Ars Technica that the concern about the impermeability of the heat shield was negated by the modified reentry profile for Artemis II. It shouldn't be an issue. And as with Boeing Starliner, I think the amount of time they took to make this decision makes clear that they didn't take it lightly. It's also about making sure that NASA completely understands the issue, not that they think they understand the issue. For example, NASA was aware of the foam shedding problem before the Columbia disaster. They even saw the foam strike the wing of the orbiter during launch. While some engineers in NASA thought this could be a serious problem, most of the upper-level management dismissed it. What damage could foam do to the reinforced carbon-carbon space shuttle? This, by the way, is called normalization of deviance. Nothing is supposed to shed during launch, but because this foam issue had happened before, they figured it was safe and moved on without trying to figure out why the foam was shedding or the possible consequences of it happening. Even after the destruction of the spacecraft, many at NASA still didn't believe that the foam strike was the culprit. It wasn't until the Columbia Accident Investigation Board tested with a reinforced carbon-carbon wing panel from the Space Shuttle Atlantis and saw the foam blow a hole in that panel that they realized the foam had been the problem all along. It's easy to think you know why something happened, especially when it's something as complicated as spaceflight. It's really easy to look back and say, of course, foam was the problem. But sometimes you can get so focused on what you think the problem is that you try to prove that it is indeed the problem, and you miss the real cause altogether. NASA didn't want to do that with Orion. They didn't want to let their theories and preconceived notions and unconscious biases direct the testing. So they tested everything. That's why it took so long. I will also say that I personally think that NASA's structure contributed to some of the delay here. The Artemis program has been spread across centers around the United States. It's a game NASA plays to keep Congress happy and therefore continue to get funding. This means that there are a lot of places with deep knowledge about any given part of Artemis, but a broadness and overview of the entire program is sometimes missing. That's why NASA established the Moon to Mars office to be able to oversee all parts of Artemis, which is good. But the thing is, Congress only authorized funding of Moon to Mars 18 months ago. Artemis I touched down in December 2022. We're 2 years out from that now. But the independent review team wasn't convened until April of this year to oversee NASA's testing of the heat shield problem and to make sure NASA was being as thorough as possible. To be clear, NASA has been working on the heat shield issue since they identified the problem after direct examination of the Orion capsule in 2022. But was it as directed or as intense as it has been since the Moon to Mars program took over? I don't know about that. My guess is that there was about a year between when Artemis I touched down and when the Moon to Mars office was in place and operating efficiently that things weren't moving fast at all. That's part of why the office was established in the first place. This is of course just my speculation, but the timing would explain why it took almost a year and a half for NASA to put the independent review team into place. So, NASA did the testing with no deadline in mind so the team could focus on every possible cause with no time pressure. They had to identify the root cause, which is a challenge because replicating complex re-entry conditions on the ground is hard. They had to test every other possibility to make sure they weren't missing anything. And then once they found the root cause, they had to model re-entry scenarios to see what the risks are and whether Artemis II could fly safely with its current heat shield. Then they had to go back and develop a flight rationale for flying Artemis II as is. It takes time, for sure. But it seems that the independent review team unanimously agrees with NASA's decision to fly Artemis II as is, and the testing has clearly been thorough. At some point, you either trust NASA knows what it's doing, or you don't, based on their history. I am choosing here to think that they did make the right decision, given everything else I've learned and seen. I do wish, though, that NASA had made the independent review team report available to the public. I'm honestly not sure why they didn't, and that makes me wary and question the decision-making, especially considering NASA has been so cagey about this issue generally. To be clear, NASA was very frank and straightforward about the heat shield problem at last week's press conference, but that is in stark contrast to the way they've treated the issue up until now. We didn't even learn about the seriousness of the problem until April 2024, when the NASA Office of the Inspector General released a report with the first photos we'd ever seen of the damage. I do understand NASA doesn't want to release information until there's something definitive to say, but as we saw with Boeing Starliner, not releasing information makes it seem like they have something to hide, and it just drives people to speculate about what's going wrong. I'm not sure what else to say here, so I will just say that I will stay on this and I will keep updating if there's anything more. But for now, that is all I have to say about the Orion heat shield issue and Artemis II. Thank you for watching. I am Swapna Krishna, and this is Ad Astra.